Okay, so for this question, we need to find the bits for tag, block, and offset. So when we read the question, we should know that total of 1024 blocks is related to block bits, and the bytes contained within each block is related to the offset. So the first thing we need to do is convert these number into power of 2. So 1024 is 2 to the 10th power, and 32 is 2 to the 5th power. And for the bits, we basically take the value of the power. So here is 2 to the 5th power. As I mentioned before, the bytes contained within each block is related to the offset, so is 5 bits for the offset, 5 bits for the offset, 5 bits, and 5 bits. Okay, and for the block, is 2 to the 10th power, so here's 10 bits. And tag is whatever that's left after we use the total bits to subtract the number of bits in block and offset. So it's 32 minus 10 minus 5, which give us 17. And for the fully associative, we only need to find tag and offset. So offset is 5, and we use the total bits, which is 32 bits to minus 5, which is 27 bits for the tag. So for two-way set associative, we basically need to find the sets first. So the way for us to find the sets is we use the uh, the amount of blocks, and then we divide it by 2. So let me do this real quick. So 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 it's gonna be 2. So it's gonna be 210 divide by 2, which is gonna give us 2 to the 9th power. 2 to the 9th power, and we take the value of the power, so it's 9 bits. And then we use 32 to minus 9 minus 5, we get the tag, which is 18. Okay, let me erase this. And for four-way set associative is the same thing. We need to find the bits for the sets first. So how do we do that? We use 210, which we got from 1024, and then we divide 2 to the 2nd power, because 4 is equal to 2 to the 2nd power, which give us 2 to the 8th power, and we take the value of the power, which is 8, so 8 bits, and then we use 32 to subtract 8 and 5, and we got 19 for the tag. So yeah, and now let's do the last question. I'm not 100% sure on this question, but I think the approach is uh we need one bit for replacement policy, and we need another bit for write back policy. So and beyond that, we need to include the bits for the tag. So it's gonna be tag. Wait. So it's gonna be tag plus replacement plus write back. All these bits times the number of blocks. So for A, which is direct mapped, we have tag is 17, and then plus one bit for replacement, and plus another bit for write back policy, and times the number of blocks, which is 1024. And then for B, which is gonna the tag value is 27, so it's gonna be 27 plus 1 times 1024. And then for C, it's gonna be the tag value is 18 plus 1 times 1024. And then for D, it's gonna be 19, which is the tag bits plus 1 10 times 10 to the 24. And you can find the results on the calculator. So that's how you do number 4 of problem 2.